Hello and welcome back to Alex's Computer Lab. We're going to do something a little bit different this evening. I'm going to build a PCB up that I am building for a friend. So this, I don't know if you can see me particularly well, this is a package that I just got in today, and let's see what kind of quality we got. So this is by a fellow YouTuber and engineer by the name of Dr. Scott M. Baker. It is one of his Atari 5200 custom controllers. So this is the board. As you can see, it's not too complicated to build. You can see the buttons on the front, you can see the connector on the top and that sort of thing. You can see the various button labels, and there you go. So interesting working upside down. So anyway, this is the controller, and I'm going to attempt to build this up. So we'll do some soldering on camera and see how that goes. It's a new experience for me, so we'll see how it is. Let's get started. I'll talk a little bit about the machine that it's going to be connected to. So this controller is for the Atari 5200. It's a game console that came out, I don't remember the date off the top of my head, but hopefully helpful me when he does the editing will put in a little subtitle with the actual date. But it followed up the immensely successful Atari 2600 home console, otherwise known as the Sears Telegames, and a few other games depending on names depending on who made it. Anyway, it was also based on the same processor, the 6502 by MOS Technologies, but it was not nearly as successful as the 2600. People didn't think it was enough of a technological leap forward, so it didn't sell as nearly the numbers the 2600 did. It's interesting in the fact that the 5200 is a near clone of the Atari 8-bit computer line based on the Atari 800. So the hardware in the 5200 is very similar. So there are a lot of games that when they showed up on the 5200 and on the Atari 8-bits looked rather similar. So anyway, let's look at what we got here. So Dr. Baker includes some instructions in the kit, and of course they're upside down, so let's hold them right side up. So anyway, not really meant to read them, but basically gives us a link to the instructions for building the kit. I've already ordered the parts. I ordered those from DigiKey, so that will give me the ability to do this build. And I just realized that I do not have any reference for what the parts are on hand. I probably should have had that on hand before I started recording this. So we're going to have a nice big blank spot where I get up and walk away and go get my iPad. Well, and then we'll get started with this again. Okay, and we are back. I have my documentation for reference for everything on this build. Most of the things on this board would not be too difficult to do even without that sort of reference, but I'm going to do it with them. So anyway, so the way you generally assemble a board is, first of all, you need the appropriate tools. So, and I of course have right here things I need. I have my little soldering mesh and my soldering iron stand. I have my iron, which in this case is that's Aouye Hakko clone. I generally would prefer to use a real Hakko, but I'm in a temporary living quarters at the moment, as I think I've mentioned previously on this channel, so I don't have access to all the normal tools that I would have. So we make do with what we have. So things that we're going to need for this. One, we're going to need a whole bunch of switches. Those are tactile switches. Here are some different tactile switches here. So we've got some of those here. We have some axial resistors. These particular ones are quarter watt 10K. I've got some caps for the tactile switches. I have a bunch of jumper shunts. I have some headers, which I'm probably going to have to trim. AT-Tiny 85 microcontroller, which is the brains of this operation. Couple analog joysticks. let's see here. I have some DB9, or as people will tell you more properly, DE9 connectors. Digital potentiometer IC. Very tiny ceramic capacitors. More tactile switches, these are brown. Some dip sockets, they'll be done fairly early. More dip sockets. As you can see, these are the type that I like. They are machine pin sockets. You can tell by those little circular cutouts on them. I like those because I think they hold ICs better. You can't tell, but these are gold. All the time when I have the choice, I will always use gold-plated sockets. Again, they make better electrical connection and they don't tend to oxidize as much. More quarter-watt 10K resistors. Ceramic 0.22 microfarad caps. I've already shown you those, and these are more sockets. So I think that's everything we need. So this is a fairly straightforward build. It shouldn't be very difficult. So, as I mentioned, when you do these builds, the best thing to do is do the shortest components first. So in that case, we've got things like those resistors. We have this capacitor. We'll do the tactile switches fairly soon, but not immediately. Certainly not the DE9s or the microcontroller. We have another capacitor. And I think that's going to be about it for the top layer here. So take all these things and move them out of the way. Put them in my storage box while I'm doing the work. So again, here's the board. And the first thing we're going to do is the 10K quarter-watt axial. And I believe there are 2 of these per board. I've got enough to build 2 different controllers, as that's, of course, makes sense. If you're going to build controllers for a game console, make enough for you to be able to play with a friend. So there we go. So I'm going to take out 2 of these, and I'll leave 2 for the second board. I'll be building that up as well. And again, when I order these, again, I ordered these from DigiKey. They're not sponsoring me or any such thing. Ha 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 ha. Of course they wouldn't. I mark these with a code on them. So you can see the resistors themselves. You can see their value, but also see where it says customer reference R1 and R2. What was my doing when I placed the order? I created a bill of materials. That makes it much easier to build out a project when you're done. So now all I have to do is find R1 and R2 on this board, and then I should be able to put them in. And I do not know where those are. So I've also got a picture of the board here. Let's see here. I don't see those at all. I'm sure they're here somewhere, but I may have to look. It could be. Nope, they're not marked on the back of the board. So this is one of the interesting things you do when you do these builds. Ah, there we go. So right there, if you can see where my thumb is, there's R1. This little sort of surround here is not required on the board, the little rectangle I've got my thumb next to, but it is common. It does make assembly much easier. Oh, and there's R2, right next to my other thumb. Let's see if we can get this so you can see it. It's not in the shadow, but the camera can see it too. There we go. There we go. Right there. So I'm going to put those in first. It's definitely not required, but one of the things I usually do in assembling is I try and make sure all of my resistors face the same direction. It doesn't really make any difference whatsoever, but it's just nice. So if I do that, I will do is I'll either pick to have the precision stripe on the resistor, top or bottom. And again, it really doesn't matter which. So I'll just go with one direction or the other. In this case, we'll see how they fit. It doesn't matter. I just want them to be the same. So some people will use a jig. You can see I folded the leg down here to do this sort of thing. You can definitely either buy or make a jig for yourself, but I don't really find it difficult to do this by hand. So I just fold them over by hand. stuff them in the board just like that, and then I take the legs on the back and I fold them flat so that it will stay in the board. Now we have a resistor inserted. I'm going to do the same with the other resistor. Again, as you do more soldering, you'll get used to this stuff, and you'll just you'll develop your own style, and you'll decide how you want to do it. Some people use tape to tape these on. Some people like to use a PCB holder. I have one, and I do use it sometimes, but I don't find it necessary. For small boards like this, I just like to hand hold. I find it's just as easy. So anyway, those are in the board. Another thing that people will decide is if they want to do a whole bunch of components at once, or if they want to do a couple and then move on and do a couple more. I tend to like to do a bunch at a time. I enjoy the assembly process, but I like being efficient. The next thing we're going to do is we're going to grab two of these little capacitors here. These are 0.1 microfarad, and they're what's called decoupling capacitors. So usually you have one of these things that goes across the power and the ground lead to every IC. And it's basically, they're what's called filtering caps, and they help you get smoother power. And they basically, because a capacitor is like a little battery, it basically absorbs some of the ups and dips in the power. So if that's not a silly enough, basic enough explanation, I don't know what is. So as I said, these go in C3 and C4. So C3 and C4, looking on this board, are, let's see here, okay, I see they're not marked. So this is U3. So U, when you see it on a PCB, usually references an IC, or integrated circuit. So I'm going to pop one in here, and again, it's a decoupling cap, so it's with that integrated circuit, and I'll fold the legs down. So there we go, we're in the board. Now same thing, and it's right here for this other IC. Again, there are two of these on the board. And there we go. So let's see. And then we just have two other ceramic capacitors on here. These are 0.22 microfarad, 50 volts. And they're for C1 and C2. And again, for reference, I've mentioned a number of PCB symbols. So C is the PCB symbol for capacitor. R is for resistor. Those are obvious, but some things aren't as obvious. So, for example, inductors, they are usually marked as L. So it's one of those things, you'll get used to it once you start building some boards. And until that point, just look it up and look up reference. I still don't know it all. I am entirely self-taught when it comes to electronics, so I look up reference material all the time as I'm building. So don't feel silly if you have to do that, or feel like everyone else knows it and why don't you. It's nothing like that. So again, we're going to stuff these in the board, and these are C1 and C2. Let's see if we can find if they're labeled. Hopefully they are. If not, no big deal. We can look it up. Again, I'm looking at a picture as well of the board, but I do not see them. So I'm going to cheat and look at the picture. Okay, that's why they're right over here. They're not labeled. They go right there. This is one of the things that would probably be a little difficult if you were new to this. One of the things you can also do is, if you're not sure about component placement, is you can go to the schematic. The schematic is the drawing of how the circuit is mapped out, what connects to what. So what I would do is look up and find, and I'll probably link the schematic for this in here. Alex hint linked the schematic in here. But anyway, you would go and find on the PCB the connections here, and then you would compare it to the schematic, and I would find what these are connected to. You can, I don't know if you can see or not, but there's a little trace out from here. So this capacitor is linked through here to this pin on U$2, which is the microcontroller runs the board. So I would just look and find exactly what connects there in the schematic. One of the ways you can find that out is the little traces can be somewhat hard to read sometimes, but what you can do is you can get your handy dandy multimeter out, and if you're not sure, you just touch one probe to one side here and the other side to the other, and you hear the beeping there. Hopefully you can, and I'll know that's connected. That's another way you need your multimeter for testing the board as you build it as well. So there we go. We've got some basic components stuffed in the board, and we're gonna take it and we're gonna move some of these leads out of the way. I try and make it so they don't cross, because if they cross and they're too near the tops of the connectors, they will get soldered together. And again, it's not a big deal. It's more work to clean them up. I am not going to use flux when soldering these particular ones. All I'm going to do is take my soldering iron and make sure the tip is reasonably clean. Which this brass mesh I'm using to clean it in is a little bit used up. You can probably see there's a bunch of solder in it. So it's a little bit more work to clean than it would be otherwise. But anyway, just make sure your tip is reasonably clean and in good shape. You can probably see this tip is decent. I prefer these wedge-shaped chisel tips. That is my preference, even when doing very small soldering, but everyone has their preference there. So another trick when soldering is, first of all, tin your tip, which is what I just did. You saw me loading a little bit of solder on there, but I'm not using that actually to solder. What I'm using that for is so that the heat in the soldering iron will be transferred effectively to the board. So when I solder, I'm going to put my iron right here, and I'm touching the pad and the leg of the capacitor, and then I'm going to do my best to not put solder directly on the iron itself, but I'll be touching the pad there and help it to flow through. So there we go. And that's how we avoid getting what's called a cold solder joint. You can usually tell if your solder joints are shiny, you're doing the right thing and things are working well. And again, I probably should have changed this mesh before I started because it's full of used up solder. So, and now sort of the next one. And again, you can see I'm holding it there for a few seconds. That gives time for the heat of the soldering iron to help the solder wick through the via. That's what these little holes are called vias. So hopefully you can see that. Hopefully the camera will focus nicely on it. So one of the things you should do is not do what I'm doing now. Right now I'm soldering for your benefit, so therefore this is not the best angle for me to be working at. So you should, when you solder with a good fan, which again I'm not doing either because it makes too much noise. The smoke you see coming off the board, that's actually burning flux, which is what helps the solder to flow. It's a wicking agent. So you don't want to get too much of that in your lungs. It is acidic. It's not like it's terribly damaging, but still it'll make you cough, and if you do this all day, every day, you could have lung problems someday. So again, take proper safety precautions. Don't do what you necessarily see me doing. It's just like they always say on TV, don't try this at home. Except I say, do try this at home, just do it the right way. Don't necessarily do what I'm doing. So, okay, so we have the first two capacitors soldered down. And those solder joints look decent. Now, we take our flush cutters, which I have right here, and we trim the legs. So everyone has a different opinion on that. Some people will say don't trim too close to the board because if you do that, you put stress on the solder joint. But what I tend to do is I will tend to come back and touch up the solder joint later with the iron, so I know that I don't have a stress joint. Okay, so we've trimmed those. You also will see I took the legs and I put them off to the side. You may have seen at the beginning of the video, assuming I didn't helpfully edit it out. I have a little pile of cut off legs there. It's something you're going to reuse. So my advice is to keep resistor legs. They're nice and long, and they're great if you need to build something custom and you need a little bridge. You can use them to do that. So there we go. You can see that is all cut off. So now we're going to go on and solder some more. So I'm going to go on and solder this resistor right here. Again, putting my iron down, and then I'll come in from another angle and I'll touch the pad and the lead of the resistor rather than directly the iron. And again, what that does is that means that the iron's heat is transferred effectively to the pad, to the leg of the component, and therefore the solder will flow through and not just go on one side. So hopefully what will happen when you do that, I don't know if you can see that or not, but you can see there's a little shiny spot on both sides of that resistor there that I just soldered. That's because the solder wicked its way through the board. It's a little bit harder to see that on the two blue capacitors that I soldered before, but that means that we got a good joint there. So I'm going to go ahead and solder the rest of these components. And we'll see if I make a mistake here and I have to do any cleanup, because obviously it's interesting to show you. Yep, right there, for example, I filled in a hole. So you'll get to see me cleaning out some holes here. That's something that normally happens. You can see that little, as the camera focuses hopefully, you can see one of the vias that I need to insert an IC in got filled up. That's not a big deal. We'll just clean that up later. There are a couple different ways we can do that. We can use solder wick. We can use a desoldering gun. I have both on hand. They were both useful for different purposes. But again, don't worry about it if that happens. Just move on. And that's the trick with almost anything when it comes to a building PCBs like this, is don't worry about it if things go wrong. Even if you do things like lift a trace off the board, which means to overheat the board and take one of these little pads off, or to damage a trace, which is a wire that connects two pads, there's pretty much nothing that can't be fixed. It just depends on how much work you want to do. So never think, oh, I've ruined it. There are certainly cases where it's, and I just burned myself there because I was more thinking about what I was talking about than what I was doing. There are definitely cases where it's more work to fix a board than it's probably worth, and it's easier just to get another PCB. You can see I filled in another hole there. Again, not a big deal. But in most cases, it's very straightforward to fix whatever problems you have. And hopefully you can see that resistor there I have soldered in place, and the solder flowed through nicely. So let's do a little demonstration of solder wick here. So this is solder wick. This is MG Chemical Super Wick. I think it works pretty well. So solder wick, what it does is it is made of copper. And it is woven. I don't know how well you can see this. I'll try and hold it up to the camera so you can see it well. I'll see if the camera focuses on it or not. I'll hold it in my hand a little bit and we'll see if that works. So hopefully you can see that. So it's woven copper. So because of that, there's a ton of surface area, and that causes solder to want to wick up onto it. So what you can do is you put your wick down over whatever you want to clear. So example, I'm going to clear this via right there, and then I put my iron on top of it and we heat the braid. And that will cause the braid to want to suck up solder. So you can see we got some smoke come up here, burning flux. And we didn't clear it yet, but you can probably see there's a little bit of solder on the braid. So we'll just go back and do it again. Another thing we can do is, if this is proving difficult, is I can apply some flux to the board, and that will help the wick to the wicking action. Again, as I mentioned, flux is a wicking agent, which helps solder to flow. So again, we didn't clear it yet. We're still pulling more solder. You can see that little dot right there. I will say that I'm just doing this to show you. Normally for clearing holes, I will use a desoldering gun. You also may see people use a soldering pump, which is either a plunger type or an electrical type. Either one, yep, and there we cleared the hole. There you go, the hole is clear. You will see there's a little bit of residue of solder on there. You can see it's still tinned, and that's okay. We can use that later. Now I'm going to go over to this other hole and do the same thing. You want to be a little careful when doing this, because if you could apply far too much heat to the board, I could definitely lift the pad right off the board. But I keep my iron for this purpose at 350 Celsius. I think that's about 700 Fahrenheit, something like that. It's not an incredibly high temperature. Some people like to solder at high temperatures, but if you do that, you have to be very careful. Again, we're having a little bit of trouble picking this up. So part of it is my tip of my iron is a little bit dry. There's not a lot of solder on it. So it's harder for the heat to effectively transfer to the wick. You can tell that actually if you put your finger on the wick like that. And again, don't burn yourself too much, but I was just testing to see if the wick was actually hot. And that shows that the heat is going into it. And we have not cleared it yet. Nope, not yet either. We're making progress, though you can see the little dots of solder that I'm pulling out. It is easier to use wick to clean up things on a flat surface than it is to do it from a hole, but it definitely does work. And you should definitely have wick no matter what. You do not have to have a desoldering gun or a soldering pump or something like that, because there's lots of other tricks for clearing out holes if you need to, but you absolutely need wick. It's something that you should definitely have whenever you buy your first iron or whatever. You definitely need to get some wick. So this one's being a little stubborn. So the next thing we're going to do is we're going to pull out some flux paste. This is the kind I like. This is MG Chemicals as well. Again, none of this stuff is particularly expensive. This is a plunger, and so I can apply it to the board very easily. You will see me use this when soldering whenever I do something like an IC. Anything where I think it's going to be a little bit more challenging to get something to stick or something to flow properly, I will use it. This stuff is a little bit gummy, so I'm going to get it to stick to the board. It wants to stick to itself. It doesn't want to come off. I'm going to take my iron and melt it a little bit. Go in there. There we go. So now we've got some liquid flux on the board. That will make the solder flow a little bit better. So then we'll put our braid back on. And we'll put the iron on. Let's see if we can get it to clean out that hole. And I can actually see as I look down here, the braid is actually turning silver, which means it's pulling up the solder. And it's still not completely clear yet. And again, the trick here is to have patience. None of this stuff is magic. It's all physics. It will work if you continue to do it. If it doesn't work in a minute, I'll pull out my desoldering gun and do it the easy way. There we go. It's still not completely clear. You do see some marks on the board right here. You don't have to worry, that's not burns. That's just burnt flux. So it's not a big deal. So another thing you can do, if you want to, and we'll try that here just to demonstrate it, is you can take one of these cut-off legs that I mentioned a minute ago and grab it with your pliers, which I have right here, and then you can actually use it to put this through the hole. And again, what you do is then you apply a little bit of heat to the leg while you're holding it like this, and use it to push the solder out. So that is something you can do. So let's try that here and see if I can demonstrate that. Let's make sure I go for the right hole. So it's that one. So then I take this and I touch somewhere else on the leg to heat it up. And that will, in a minute, will get the leg hot enough, assuming I have enough solder on my iron tip to be able to heat up the leg. I'll transfer some heat in there. There we go, and it went through. And then we'll pull it out. And all we've done now is we have successfully put some more solder on the board. So that didn't help us a lot here. So again, what you do is just you need to get it hot enough that you can pull it out. So this is not helping us in this situation, so we'll go on something else. So I'm going to give one more try to the wick, and if that doesn't work, then I'll pull out the desoldering gun. And you can see there's all of a sudden a bunch of solder just flowed into here. The wick is turning silver rather quickly. It's because of that new solder I just added. And now we're back to it being mostly clear, but not completely. Okay, so you get me to demonstrate the desoldering gun, because I have done this enough. So I have demonstrated that's how wick works. As I mentioned, clearing holes is not one of the things that is easiest to do with wick. So this is my desoldering gun. This is a real Hakko tool. It's Hakko FR301. I am a massive, massive fan of this tool. I bought this thing, this particular one, about a year and a half ago or 2 years ago when it first came out. I had the predecessor to this, the Hakko 808. I really, really like that. I like Hakko particularly because they make parts and schematics available for all their tools. That's something that every manufacturer used to do, but not everyone still does. Hakko does a great job of it. So again, they're not sponsoring me, but I love Hakko. So to use this gun, there's a little button on the back that causes it to heat up. You hear the noise it makes. It's actually got a pump inside. It's got a setting here for what temperature you want to have it on. Right now this is set to 1.5, which is about 375 degrees Celsius, or about maybe 700, again 700 Fahrenheit in my conversion from Celsius to Fahrenheit. It's not great. But anyway, so then other than that, it's just like an iron. We touch the board, we heat it, and then there we go. There's vacuum, and we pull it out. So, is that clear? Yep, and that is clear. So you can see how handy that is. And we just click it off since we're done. So these soldering tools are incredibly useful. They're absolutely not required to get started with soldering. You can definitely use much cheaper stuff. You can definitely make do with just wick. I could have definitely cleared the whole with wick. It just takes more patience. And patience, by the way, that is a critical aspect of this. You definitely do not want to be impatient. Also, when you're just getting started soldering, you will make mistakes. You'll definitely mess up boards and things like that. It's just not a big deal. All this stuff can be repaired. If you really have trouble, find a friend who knows more about soldering than you do and ask them for help. Or if you don't have one handy, just go online. There are lots of forums and boards and things like that where people will help you. And if you want, you can ask me. I am certainly not a master, but I know what I'm doing well enough. So I'm just going through, and I'm going to flex these leads back up again. You notice I do not save the legs of the capacitors. They're short enough that you can use them, of course, but they're pretty tiny. So there are not too many scenarios where they're incredibly useful. Back in my normal working area, I have a whole drawer full of cut-off legs, which is probably silly. You don't need that many, but I have trouble with throwing away useful things, which is why my desk and my workspace are so cluttered. My wife is an incredible angel to put up with me. So anyway, all those are done. I mentioned before going back and touching up the joints because I have clipped them, so that clipping them puts stress on the joints, because again I'm flexing legs, so I just go back and touch. Just touch enough to remelt, and that's it. And that's all we have to do. And we attempt not to fill in any holes, which again, it's a little more difficult than it would usually be because I'm working at a weird angle. But you can see the color change on the joints again as it heats up and then flows. So there you go. Now therefore we know now there's no stress on those joints. So that is all done. Thank you for watching this video. If you like what you saw, please like and subscribe, and come back and join me for part 2. Thanks again.